Hi, Sportster Paul here. Today is our first impression of BobCAD CAM. It's a less expensive package. It's very popular. A lot of people use it. My first impression hasn't been that great. The good thing about it, it's stable. With SolidWorks CAM on my weird machine, old Windows 7 laptop with 2 video systems and 4 monitors. With SolidWorks CAM, if I close the dialog box on a particular monitor, it would just disappear. And when I tried to get that dialog box back, I had to go hunt with it with screen resolution, moving the screen around to different places or resetting the registry. Visual Mill had similar problems. It had a problem with an installation where it couldn't install one of the visual C++ libraries because I had a newer one. And maybe that's why it was unstable. All of them are crashing, including BobCAD. It crashed a couple times, but with Microsoft development tools, you just expect that. Memory leaks are going to happen and it'll crash. So the stability of BobCAD has been great. In general, it hasn't been doing flaky things like changing dialog boxes and doing stuff like that. The other thing I love, in this demo version, which anybody can go get, you can save the file. And it saves all the toolpaths and all the work you've been doing for hours. And the way they get around like doing something for nothing, well, you can't open that file in the paid for version. So that way you can't get people getting a demo, doing all the work, then buying the paid for version for a month and then sending it back. So I understand that. So that's really cool. What I don't like, well, there's no help system. Not one that I could find. F1, question mark, help, Visual Mill was full of help systems. That's a business decision where it's like, well, we can charge people to do help, right? We can make it not full of help files, and that way when people need help, they can pay us for help. And that's a perfectly valid way to do business. But that doesn't help you at 4 in the morning when you're trying to do something and the business is closed and you can't get a hold of them to get a support person to pay money to answer your question. So I'd much rather have a help system. Part of that also, there's no undo that I found. If you go to start undoing stuff, it undoes whatever you did in SolidWorks. You make a sketch or something and say, wait, why are we back there? I did all these changes in the BobCAD, and it's not undoing that. So that's part of the no help, no undo. They have a wizard mentality. I assume people complain, there's all these dialog boxes, it's too complicated. So their solution was, we'll make a wizard. And the wizard is just another dialog box with 10, 15 more dialog boxes inside of it. And they're spread out and they're named kind of funny and they do funny things. They're more than willing to cut through the model. Here's one picture, okay? Here's one picture where I didn't understand that system compensation really means, translate, what side of the toolpath, what side of the geometry you're going to cut on. So you can see here it's cutting half of one, half the other. Then there was just a normal, I tried to do a 3D of those ramps. Look at this one. It's hogging through the whole part. Now I would think software smart enough to do all this stuff is smart enough to say, if I'm running an end mill through the solid model, I'm doing something wrong, right? That's just maybe because, well, it used to be, well, we can add fillets and put chamfers on where really the solid model has got solid stuff. Oh, I want to chamfer that and ignore the fact that I'm cutting through the model. Maybe that mentality makes software people think it's okay to carve up the model. The real, all those things that you kind of work around, the real issue I have is the simulator. First off, you can tell it's hacked in. It's the same simulator code base that they use in their standalone version. This is the SolidWorks version. Well, they don't use SolidWorks animation tools like CamWorks and Visual Mill where you're still in Solid. You can tell it's just SolidWorks doing this little animation. What BobCAD does is they just open a window and run the same code that runs in the standalone. And if you're used to the standalone, maybe that's great. It works the same way. But to me, it's like, well, why are you inside SolidWorks but not really inside SolidWorks? It's kind of a, kludge to do it that way. The other problem with the simulator is because it's their simulator and not something inside SolidWorks running, to rotate the part in space, it's not middle button like SolidWorks, it's the left button. To pan, it's the right button in the simulator. Whereas in SolidWorks, what is it? Control middle button, I think, pans. And I prefer the sad thing is I prefer the way BobCAD does it, but it's different. So after you're in the simulator a while, you go back and, I'm clicking the wrong button because I think I'm still navigating and the zoom wheel works backwards. because they matched what SolidWorks did, but I reversed the SolidWorks zoom wheel, the direction it goes, to match what my TurboCAD does, which you can't set one way or the other, my old TurboCAD. So that was a headache. Then the final thing that the simulator really makes it hard for me to deal with, they don't have a compare function like SolidWorks CAM or Visual Mill did. You click a little button, you do the simulation, you click a little button, gouges are in red, extra stock is in blue, there's a gradation and you can see the colors change. In BobCAD, you run a report and then you say, show me, and it gives you little text boxes all over. I'll show you. To me, half of them don't make sense. They're cluttered, and it's just not the way I want to learn what is going wrong. So I don't feel confident about this. It waves a tool over a part, and it carves away stuff, but it's not nearly as confident building. Looking back at the Visual Mill, which was the most unstable one for me on my particular machine, it's had the best way to kind of, let's improve this, and let's make this, and let's make radiuses on the corners, and let's make really accurate parts. I felt most confident using that one. So let's get into it. Here's the SolidWorks. Let's go up and look at it. I just started it. Like all of these programs, they default to have the add-in running. I turn all that off, so now I get to go add-ins. You can see here's the SolidWorks CAM, here's Visual CAM, here's BobCAD. So I turned it off at startup. I don't like things starting. You can see it takes a while to load. It's a big program, 13 seconds last time it loaded. Turn it on. It's thinking, it's doing its load. Now they're being cool. They're saying, hey, you're going to pay for it? No. Then you can run it as a demo. When you do run it as a demo, though, the parts you can save here will not open in a paid-for version. It's still thinking. I think I clicked, yeah. So it took that long. It's kind of bloated to take that long. Then let's do this. File. We're going to open. This buddy that emailed me this part, Dave Rui, mechanical engineer, industrial designer, machinist, man of all trades, Renaissance man, and did this genius little 3x4 inch by 1 inch part to trip up CAM systems, to make it kind of difficult when they try to do this automatic feature recognition. BobCAD, I don't think, even claims to do automatic anything, and I prefer that. So we'll start with this read-only part. It was done in 2019. It's read-only, you open it read-only, yeah, because I didn't want ever to overwrite this and confuse myself for what he did and what he sent me. And he did toolpaths in SolidWorks CAM, and we had some fun with that. That's other episodes you can watch. So here it is. First thing I'm going to do is save it as, save as a copy and open, and save it as this BobCAD 1. So when I go on my website and post these files, I'll post both of these files. The way it started as a read-only that you won't be able to mess with. It already exists, yeah, because I've been practicing all day. It's an older version. Dave's part was done in SolidWorks 2019. This is just saying, yeah, I got a 2020. It's in demo mode. The tree will not be loaded in licensed mode. This delighted me that I can, go home, save it, come back, and still keep going and making these shows for you. So that's not a problem. So here's the part. Oh, close the original document. So I think this is always hover and make sure you know what you're working on. BobCAD 1, first episode, first impression, solid part. Okay. So here's this tricky part, Dave. It's got a little 3D-ish, these two slopes. It's got two breakout holes, and that's what befuddles a lot of this stuff. This hole breaks out. They're all quarter 20 tapped holes. This hole breaks out. A through hole, and then a blind hole on the bottom. 5 holes. All the automatic stuff like SolidWorks CAM, it wants to do 2 holes from the top, 3 from the bottom. Visual Mill couldn't do them all in one batch. It wanted to separate them into 2 batches. Even when I use the hole wizard on this thing, it ends up with 2 separate batches of holes. The 2 holes separate and 3 holes separate. So we'll get to that in a couple of episodes. Meanwhile, it's got this little protrusion here. Dave's a smart fellow. It's meant to be done with a 1/4 inch end mill. So these diameters, all the fillets in the corner, they're not 1/4 inch because that means the tool would come up and stop right in the mathematical corner and then go in a different direction. Instead, he made these diameters 0.26. So there'll be a little arc. So when it's doing this outer perimeter here, the tool never stops. It goes in, the X direction, then it does a little arc, and now it's going in the Y direction. And it's more continuous motion instead of stop and start, and tends to scar the sides of the thing less. Like I say, guy's a genius. So here we're going to start. Here is a little housekeeping. We pull it out. Okay. This is the cam tree. This is what you're paying for. This is Art Manager, and this is like all the router stuff where eagles you carve and do carvings and take pictures and turn them into engravings. That's what that's about. I don't care. I might use it, but I'm not going to evaluate it. This is the post processor. It's all empty because we didn't post. They will post, but only 4 or 5 lines. So you can see the header and the footer, but you're not going to get much other than 3 or 4 lines. I guess it might be valuable to help you understand your setups if you got part 0 right in both. So here you are, empty. It turns out the way to start, you say new job. From template, I didn't see any templates I could use. It's a milling job. You say start stock wizard and it won't do it, but that's life. This is the mill. Yeah, 3-axis, 3X mill. It's not a plasma cutter. System default. Just say yes. Now it's asking, it didn't do the stock wizard, it did workpiece wizard. What are you cutting? Well, you just hit it. Yeah, this big thing I just have. Say yes. So now it's got that. Now it lights up stock. You do the stock wizard. And this, once again, I like it better than SolidWorks CAM, where you can't put the overall dimensions in the way you buy stock. This one lets you do that. Bounding box, see now the stock is just as big as the part. You can see it adds stock here. We want stock all the way around, so we can show you cutting perimeters and decking the top and decking the bottom. Let's see, bounding box, enter. So we want this a 1/2 inch bigger. And see, they keep it in the center. See, that's what's so cool about this. Here you want a 1/2 inch, so you got 1/4 inch of meat on each side. And then for thickness, I want plenty of meat down here to hold the vice jaws. And a 1/2 inch, see, those are the kind of numbers you can go to Midwest Metals and order the stock. I want a 1/2 inch thick, 3.5, 4.5. You get it all day long. So that's pretty good. The next issue, I want to put it in the vise like this with the solid jaw back here. So that in my particular machine, Avid Benchtop Pro, beautiful little machine, router style. Positive X is towards the right, positive Y is to the back. So you get to do that, I think, here by saying X direction is here, and then reverse it, and it did everything we needed. It rotated about X. Now, positive Y is towards the back of the machine, positive X. That's just the way my particular machine works. You might home in a different place. Z is up. All that's normal. I think it's okay to leave this in the center here, because this is a stock thing. So, okay, the stock is kind of lined up. Then this is the one you say edit, and here is where you pick an origin. I think you can go there. And of course, it's changed it. Software people, X there, and of course, it's going to be wrong, Y here, and that's wrong. So now we actually have what we want, what's called part 0, where you use an edge finder and find these 2 edges, a Z height to get that exact height, and that's going to be 0, 0, 0 on your machine. Part 0, not homing, which is machine 0. Okay, so there you go. You're ready to go. You're going to find this corner when you do your setup, and now everything will match where this computer thinks the part is and where it is in your machine. I don't think we're going to get to this in a minute. This will burn you. Way down here, work offset. I'll show you what happens bad there. It's easy to fix. All this stuff is easy to. Oh, I did make a mistake. They make it flush. Stock wizard again. And so I think you have to enter the origin and then just go up in Z. 1/10 of an inch. I want to go up 1/10, so I got meat on the top to cut. Meanwhile, I got 4/10 of an inch on the bottom to hold it in the vise. And then after we do the top and the perimeter and all that, you can flip it over, grab the part itself in the vise, and then deck off the bottom, shoot the 5 holes. So that's working out good. All right. Moving along, machine setup. Okay, we got our 0 set. Fixture, that's encouraging. The fact that it just has the word fixture here tells you every machinist I know has hit a clamp and busted a tool and maybe hurt the spindle. So that's telling you, yeah, this is a thought out program, and you'll be able, I assume, to model, reselect or remove. Well, I guess you have to model it. Maybe that you do an assembly or draw it. I'm not sure. That'll be lesson number 52. Meanwhile, so you're in machine setup 1. You're coming from the top. It's smart enough, apparently, because we put Z in that direction. We want to do phasing. Excuse me. We want to face the deck off the top of this. So you say mill facing. This is this wizard business. Just because you call it a wizard does not make it simple. Stuff is in funny places. And all right, so what do we want to do? One of the things, it's telling us the feature. It's already smart enough to know that the top is where it's going to go. It's this is how the clearances, where it's above, how it moves around without crashing in. This says the top of the feature is 1/10 of an inch up, and the total depth is 1/10 of an inch down to get to the top of the part. That's all cool. Machine strategy, well, facing. That's your only choice for this one. Posting, work offset 1. That's going to be important later. Facing, no choice, rough. Now, what this really means, it's pictorial language. Like even before hieroglyphics, there were pictorial languages. That little yellow thing is an end mill. And so this is supposed to be tool that does roughing. It's a 1/2 inch. My little mill, I want to use a 1/4 inch. So you go to the tool crib, add tool from library. I want a long 1/4 inch, because when we start doing the perimeters, you'll want that flute length so you don't crash the smooth part of the end mill into the side of the part. You're not supposed to do that. Only flutes are supposed to touch as it rotates. So this long one will do the job. There it is. It left the rough, but it all works out. Watch how nice this is. Now, the other thing is, well, let's go look again. See, it took away the one that we don't use, added this one, but it's 4 flutes, and I don't want 4 flutes. So you go here and say, well, actually, I have a 2 flute. And you say, I forgot what I did. Oh, you just type it in, and then you say tool crib. It's made a new tool that has the 2 flutes in it, which is kind of cool. So you say, yeah, okay, that's what I want. So that's okay. Patterns. Let's do it. Compute. What the heck is going on? It's going an inch, about an inch, right? It's an inch thick. What's this big overshoot? Why on earth would it ever default to that? There's a lot of things programmers do that make me wonder. Back to edit. Okay, what looks like about an inch? That's not it. Pattern. Oh, look, patterns. How about on workpiece? And they say on workpiece. They should really mean on stock, because if it was doing the workpiece, it would be undercut it. Compute. Okay, now they make sense. Right height, right depth. Life is good. Then what I like to do, a little housekeeping, facing. Enter. Now, let's show you the simulator, because that's one of the things I complained about. We should let you see. Here's where the simulator comes in. Little button. It's not evident. Visual Mill's great. They got a big wide tab with letters on it. Simulation. Wonderful. Oh, I did a hide all. Sorry. Simulate. So here comes the simulator. You can see, right? It's got a close button here. This is just their code base that runs in the standalone version. They've opened a window in SolidWorks and they're running their standalone code. That's why the right button does this instead of the middle. That's why the left button does this instead of the middle. The right button does panning instead of shift, or what is it, control middle. And then zooming is backwards from the way I set up my thing. So all of that has been tripping me up. You can say run. There you go. Pretty cool. You can say restart. If you're in a hurry, just say that. It does it instantly. I think you can do steps forward. You can do next stop. All basic stuff. Nothing too horrible. Now, what burned me, workpiece stock, the way it defaults, and I don't know why everything needs 2 clicks. It defaults to show you this. Oh, look, a little Tormach, or I ain't a Haas. And notice how it's buried the part down into the table. Because when we go to cut the perimeter, you're going to get this error message. Tool crashing into table. And the problem is, the first thing I did, I don't want to look at a little tool. I want to just look at the part. That's the kind of simulation I'm used to. So it took a while to figure out, well, the way to solve that, close it, go back to fixture 1, do that edit, go down here, and in work offset number 1, you're not going to change the number, enter, put this part 2 inches up and say yes. There's another way. I think you hover this or just press here. Yeah, you just hover. And see, there's our 2 inches that already went in. We can reapply it. Now, if we go simulate again, there it is, but now do this goofy. See, now it's up in the air as if it were in a vise. So we won't get any of those tool crashes. And here's the picture of the way it starts out life buried in your mill. And they had a video, thank gosh, that showed why you have this problem. Okay, so facing went really, really good. I mean, some goofy stuff. I don't like these wizards. Why it overshoots the tools, not a crisis. Let's do the next thing. Can we neaten this up? No, I guess not. I wish it had a little more choices, like I'm doing a pocket, I'm doing a flat. No, it's just a 2-axis kind of thing. Select the geometry. Now, we want to do the perimeter. SolidWorks CAM has a whole thing, do perimeters. Didn't do what I wanted, but at least the heart was in the right place. Visual Mill, I had to pick the top because I couldn't get it to cut 20 thousandths below when picking the simple 4 ones on the bottom. But BobCAD lets you just pick these 4. Okay. Then it's decided this machining strategy, oh, well, everybody wants to rough and finish. Everybody wants to do that in life. I guess I'm not going to, you can delete it, right, and get down to one operation, because a lot of high-speed machines like mine, you're not really roughing and finishing. You're just buzzing, taking small cuts. But let's finish. No, let's not finish. Let's compute. Okay, where are they? Where's the toolpaths? Turn it upside down. Not only are they inside the part, this is my thing about they're fine with cutting through your model. It's in the wrong side of the geometry, and they're way far apart. What's going on? I mean, there's one. They're not even being clear. Okay, the outside one is rough. The finish is inside the outside. They're not even seeming. This is what's going on there. Edit. Okay, the reason there's 2 of them so far apart, the finish, they've decided to use a 1/2 inch. That's the kind of their default. Okay, so let's go to our tool crib. Let's pick that same 2 flute, this one here. Say, okay, it's changed it to a 2 flute. So if you compute now, go, at least now it's making sense. And look, they're off. And well, that's because, and this is a machining term. This was my ignorance, not understanding. Stock allowance, rough, that's tool. That should really, patterns, this isn't it. Parameters, side allowance. Profile rough, parameters, side allowance. It's going to leave on this 10 thousandths of it, 10 thousandths, 0.01, all the way around. And that's what your finish mill is going to fix. Okay, I can live with that. And sure enough, when you go down and look at the parameters here for the finishing stuff, side allowance is 0. Now do notice that when we change that end mill, it decided, well, that's a roughing mill, because that's maybe where you first defined it. So this isn't saying rough, finish is finish with a rough mill under it. And why this happens, what I'm doing wrong, haven't figured that out yet. So you think you're okay, but you're not, because you're on the wrong side of the part still. This took forever. And this is a problem. It's patterns. Now I looked at this mostly empty dialog box and I saw system compensation with a red, oh, that's what all my machinist buddies call cutter comp. Cutter comp is when you have an older tool and you grind it, you have it resharpened, and so it's not a 1-inch tool, it's a 0.98 or a 0.999 or something. And then in the machine, not in the software, in the machine you type in cutter compensation. And then the toolpaths all adjust so that the edge of that smaller, tiny, smaller cutter, slightly smaller, cuts the right surface that you're trying to cut. Cutter comp. So I passed over, this can't be it, this can't be it. Half an hour. Now this is where you decide what this should be labeled is, what side of the geometry are you going to cut? That I'd understand. You got plenty of space here. Oh, I get so frustrated. So go right. I guess if you go on, where were we? We dare not get this confused. And then go, that's the roughing pattern. We want this pattern also to be on the right side. I found no way to figure out whether you're climb or conventional cutting. Is that, it can't be the same as right left, because that's where you're cutting apart or not cutting apart. Direction, machine sequence, closest, that's jumping around the things. Advanced, I'd really like to see the words climb and conventional somewhere. No. So you say compute, okay. Now it's got, here we'll look from the top. Now it's got the toolpaths on the outside perimeter like we want. It's got them right at the bottom of the part because that's where we selected that geometry. So there's more fun. I'm doing this tediously so you get the what it was like for me learning this. Edit. I think it's the feature itself, total depth in inch. So it's saying the top of the feature is 0. Fine. The total depth. Well, see, this is the thing. It's like Visual Mill, what I love. You can say pick top. And you can just say, well, no, you're going to start machining this perimeter here. And you say, okay. And then it's not going to change, right? Because it knew enough to make it an inch low because that's where the geometry was. But if you pick bottom and say there, okay, an inch. But we want to overcut it a little, right? We want to go 20 thousandths more so that when we flip it over and deck off that bottom, there's not a razor sharp edge. So we're going to add 20 thousandths here. And it's smart enough to do that. And then I'll save you more tedium going back and forth. You notice it's doing it all in one whack. And that'll break the end mill off in my world. So then you go parameters, single step, yeah. Multiple steps. I don't want to go ½ inch at a time. This is a router style mill. I want to go 0.125. Let's go eighth of an inch. The two cuts is no longer true. The only way I found to make that true is go like that and that. Okay, now it'll take 9 cuts and to make the math even depths, it's 0.11. Then this parameter, same trick. 125. Bang, bang. Say compute. There we go. Now one of the things I should have done right away, tools. God, I hate that the scroll wheel doesn't work on this long menu. You gotta go all the way down. There's a triangle down here you gotta click. My screen's 1200 tall, so that's why you don't see it. Options, document properties, units, here, 4 places like all my machinist buddies love. Go back to and look at, let's light that back up. Edit. See, now you get enough significant digits when you do these parameters. Okay, the depth of cut's going to be, that's how it gets, even depths, defined depths. Well, that's kind of wrong. That's what happens if we do 125 again. No, that's what it has to do to make 9 passes. Okay, so that's helping us. I don't mind that. Compute, I think we're all done. Let's do the simulation again. Simulate. Oh no, it's up in the air. So get here because I don't want to look at that. You can go fast forward. Fine. Restart. You can run. There's the finish. And we're done. So that's the basic navigation. We're going to stop now. Just 2 operations. Half an hour of explanation and complaints and whining about stuff. Oh, still not done. It's not going to be a half hour. See how it's left the little posts up here? And that was something, I don't know if you want to call it a shortcoming. When I say rough, to me that means, hey, if there's any stock anywhere, hog it off. Apparently that's not a universal language in the world. I would think, okay, so we just care about the roughing operation. So we know to be up in this area. See, this is why I think this whole wizard thing's silly. Patterns, this is where you do it. Side roughing. And you would think, oh, look, stock remaining. That's those little tiny corners. No, because there's not stock remaining on the long toolpath runs. Apparently, it thinks it's okay. So you have to say step over, and it'll still won't do anything until you give a number here. And like I said, 125, I've been playing around. Compute. Now it's got a toolpath. See extra toolpaths all the way out here. And the other nice thing about that, it's not just getting rid of those corners. It means that the end mill isn't taking too big of a hog. It's taking tiny little corners because this is not as rigid a machine as a Kitamura or anything. So we'll just do it once again. Simulate, run, and now those little corners will be gone. And I guess my next project is to find out how I get this thing to do climb or conventional or whatever's going. Maybe that's defined in the tool. You never know where software people will put stuff. So that's it for today. We're right about on schedule, 30 minutes gone. Next episode, we'll keep doing more of these features, showing you more and more fun. Like I say, the simulator leaves a little to be desired. We can real quick, where do you go? Verification, gouge excess, show excess. What's going on here? I think because there's a pocket underneath. It's 75 thick. It's finding a problem here, but you'd think that would be 4/10 of an inch with the 20 thousandths taken off, but it's not. 0.304. To me, this is confusing and worse than useless. So the simulator here, compared to that, click the button and the colors appear for what's gouged and what's excess. I kind of insist on that. But we're going to keep with it because maybe this simulation's okay for you. It did teach me stuff, just the fact that it's waving a tool and showing stuff being carved. So that's it for today. Catch you next time. Hope your CAM journey is as much fun. See ya.